Recall that the unit circle is a circle whose radius is 1 and whose center is at the origin of a rectangular coordinate system. On this unit circle, let theta be the angle measured from the positive x-axis to the point P, whose coordinates are x, comma, y. In the diagram shown, angle theta terminates in quadrant 1. Exploration 1, find points on a unit circle given an angle theta. Since theta can be any angle, the point P can be found for some basic angles. Number 1, fill in the values below to explore this. If theta is 180 degrees or a straight angle, that will determine point P1, which is labeled here, circled with the red laser pointer. And the coordinates are x is -1 and y is 0. If theta is 270 degrees, which is 180 plus 90, then point P2 is determined, which is on the negative side of the y-axis. And the coordinates are x is 0 and y is -1. If theta is 90 degrees, then the point P, subscript 3, is on the y positive axis, x is 0, and y is 1. If theta is 360 degrees, one full revolution, then point P has coordinates x is 1 and y is 0. If theta is 0 degrees, then point P again is x is 1, y is 0. If theta is -90 degrees, a negative angle means the angle is opening clockwise, CW, and will terminate at point P2 on the negative part of the y-axis. X is 0 and y is -1. Now let's pause here, and from point P in quadrant 1, let's draw an altitude perpendicular and indicate the right angle. And note that x is the coordinate of point P. Also, x is the length of the horizontal leg of the right triangle formed by the altitude. Y is the length of the vertical leg. Also, y is the coordinate of point P. As theta changes, and theta is a variable, remember, both x and y will change. In quadrant 1, as we open the angle counterclockwise, x is decreasing, y is increasing. X is decreasing to 0, and y is increasing to 1. Other terminology to know is that given angle theta, the horizontal leg is also called the side adjacent to the angle. And adjacent is going to be abbreviated capital A. Across from theta, the vertical leg is called the side opposite. And for short, we'll use the letter O. Across from the right angle is the hypotenuse, which we'll abbreviate with capital H. Trigonometry gives us the word sine and cosine to describe the relationship between the angle and the point on the unit circle. Keep in mind that any variable, in this case t, can be used to denote the angle measure. Definition: let t be a real number, negative 0 or positive, and let P have coordinates x comma y be the point on the unit circle that corresponds to angle T. The sine function associates with angle T the y coordinate of point P and is denoted by the sine of angle T is equal to y. Note that the denominator of y is a 1. So that's y over 1. And this is a ratio, y to 1, where y with respect to angle T, or theta in the diagram above, is the side opposite. Length of the side opposite angle theta or T. 1 is the length of the hypotenuse, abbreviation HYP. So a short memory device or mnemonic is the sine of an angle T or theta is the ratio of the side opposite to the length of the hypotenuse. And this can be remembered as S for sine is the ratio of length of the side opposite divided by the hypotenuse. And that's remembered as SOH, S-O-H. The cosine function associates with angle T the x-coordinate of point P and is denoted by the cosine of angle T equals x. The denominator of x is a 1, and x is the length of the side adjacent and 1 again is the length of the hypotenuse on the unit circle. So to abbreviate, we'll use this mnemonic. The cosine of angle T is the ratio of length of the side adjacent to length of the hypotenuse. And that will be memorized as CAH, ka. So cosine is the ratio of length of the side adjacent to the hypotenuse, ka. Knowing this relationship, use the unit circle chart, and you can confirm it with a calculator set in the appropriate mode, degree mode, or radian mode to verify the following. The sine of 180 degrees means the y coordinate with an angle of 180 degrees. So when you're first learning this, you want to quickly draw what represents an angle of 180 degrees, and the point on the unit circle will have an x coordinate of -1, or a cosine value of -1, and the sine of 180 is 0. Cosine of pi radians means the x coordinate for an angle of pi radians is -1. Pi radians equals 180 degrees. The sine of 360 degrees means after one full rotation, one full revolution, the y coordinate for the point that is determined is 0. The cosine of 2 pi radians, which represents 1 full revolution, is the x-coordinate, which is positive 1. So you want to picture or quickly draw an x-axis and what represents 2 pi radians, or 360 degrees, will determine this point P, whose x-coordinate is 1 on the unit circle. The sine of 3 pi over 2, you may think of that as 1.5 pi radians. And if you draw 1.5 radians from 0 degrees, it would be pi and then 1.5 pi, or 3/2 pi, determines this point on the unit circle, and the y-coordinate is -1. The cosine of 270 degrees, where 270 is 180 plus 90, will be the angle that terminates on the negative y-axis, and the cosine value is the x-coordinate, which will be 0. The sine of 0 degrees is the y-coordinate of 0 degrees, which is 0. The cosine of 0 radians is the x-coordinate, which is 1. The sine of 90 degrees on the positive y-axis is the y-coordinate, which is +1. The cosine of 90 degrees means the x-coordinate when theta terminates on the positive y-axis is 0. The sine of negative pi over 2 is an angle that opens clockwise and terminates on the negative y-axis, and the sine of the angle is the y-coordinate, which will be -1. The cosine of -90, again, is a clockwise angle terminating on the negative y-axis. So a quick sketch. -90 degrees is clockwise. That determines a point on the unit circle, P, whose x-coordinate is 0. From these definitions of the sine and cosine function, we have the following definitions. Let t be any real number and point P have coordinates x and y, be a point on the unit circle that corresponds to the angle t. If x is not 0, the tangent function associates with t the ratio of the y-coordinate to the x-coordinate of point P, and is denoted by the tangent of angle t is the ratio of y to x. And since x is in the denominator, that's why we have to have x not equal to 0. And then we should think about, when is x equal to 0? Well, here's a sketch of the unit circle. X will be 0 for angles that terminate on the y-axis. For example, 90 degrees, or pi over 2, 3 pi over 2. For those angles, x will be 0, or the cosine of the angle will be 0. So the ratio of y to x is also the ratio of the sine of the angle t divided by the cosine of the angle t. If y is not 0, which is a restriction on y, the cosecant function is defined as CSC of angle t is the reciprocal of y. And this is the same as 1 divided by the sine of angle t. Now, since there's a restriction on y not being 0, that leads to the question, for what angles is y equal to 0? Angles that terminate on the x-axis will have a y coordinate of 0. So for example, 180 degrees or pi radians, y will equal 0. So the sine value will equal 0, and the cosecant function value will be undefined since the denominator is 0. Same with 0 degrees or 0 radians, or 2 pi radians, or 360 degrees. Y will be 0, the sine function value will be 0, and since 1 divided by 0 is undefined, that means that the cosecant function will be undefined for those angles of pi radians, 2 pi radians, or 180 degrees or 360 degrees. Next definition. The restriction on x is that x cannot equal 0. The secant function is defined as SEC of t is the reciprocal value of x, or 1 divided by the cosine of angle t. Since division by 0 is undefined, x cannot equal 0, and angles whose cosine value is 0, such as pi over 2 or 3 pi over 2, will make the secant function undefined. Lastly, if we restrict y from being 0, the cotangent function is defined as COT of t is the ratio of x to y, which is the reciprocal of y divided by x for the tangent function. This also is the ratio of the cosine of angle t divided by the sine of angle t. It should be noted to separate the t and cotangent from the argument t, which is the angle. It's better to write cotangent COT, open paren. The argument is the angle t, which is a real number for the radian measure of an angle. Example, find the values of the trig functions using a point on the unit circle. If point P has coordinates negative 0.2, which is 1 divided by 5 is negative 0.2, and 2 square root of 6 divided by 5. Now let's, on a calculator, enter 2 times square root of 6 divided by 5 to get the decimal value. The decimal value is approximately 98 hundredths, close to 1. This is a point on the unit circle that corresponds to the real number t, where t is an angle measure. Now, since x is a negative value and y is a positive value, x less than 0 and y greater than 0, that means that the point P lies in quadrant 2, Q2. So if we sketch roughly what the angle T is, so here are XY coordinates. Here represents the unit circle. If X is negative 0.2 and Y is almost 1, then the angle opening counterclockwise would look something like that, so that when we project X from this point P down, the length of X is about 0.2 versus the radius, which is 1. And Y, the vertical distance, is 0.98, close to 1. So this would be Y on the vertical, 0.98, and X would be relatively small at 0.2. Now the coordinate X is negative because the point is in quadrant 2, but the length of X on the right triangle is positive 0.2. The sine of the angle T is the length Y, or the distance Y from the x-axis, which is the Y coordinate, 2 squared is 6 divided by 5. The cosecant function, cosecant of angle T, is the reciprocal value, which is 5 divided by 2 square root of 6. Next, we would want to rationalize the denominator. So we'll multiply 5 divided by 2 square root of 6 times a form of 1, which is square root of 6 divided by square root of 6, which gives 5 times square root of 6. And the denominator is 2 times 6, which is 12. And we'll leave it as an exact answer without a calculator or decimal. The cosine of angle T, let's pause here and go back to the graph and draw an angle T that terminates in quadrant 2, determining point P and coordinates X and Y. So that angle T is associated with an X value, an X coordinate of negative 0.5 for point P. The reciprocal value is the value of the secant of T. So just invert negative 1 divided by 5, and that equals negative 5. The tangent of angle T is the ratio of the sine of T divided by the cosine of T. Also, this is the ratio of Y to X. Keep in mind that Y is positive in this situation, and X is negative. So the tangent function value is negative. By substituting the values of sine and cosine and simplifying, we'll multiply numerator fraction times the reciprocal, positive 5 over negative 1, and that equals negative 2 square root of 6. The cotangent of angle T is the reciprocal value, which is 1 divided by negative 2 square root of 6. These values are reciprocal values. Then we would need to rationalize the denominator, multiply by a form of 1, square root of 6 divided by square root of 6. So the cotangent of angle T is negative square root of 6 divided by 2 times 6, which is 12. Find the exact values of the trig functions of quadrantal angles. Quadrantal angles are angles where the terminal side is on an axis, one of the two axes. Complete the following chart. So in the first column, we have 0 degrees, which equals 0 radians. At 0 degrees, the y-coordinate is 0. And the x-coordinate, or the cosine of the angle, 0 degrees, is equal to 1. The tangent of theta is the ratio of y to x. So if we look at the value of 0 in the third column divided by x, which is 1, 0 divided by 1 equals 0. The cosecant of theta is related to the sine of theta, and it's the reciprocal value. However, 0, which also could be expressed as 0 divided by 1, or 0 divided by any non-zero number, when you try to form the reciprocal or invert 0 divided by 1, you get 1 divided by 0, which is undefined. The secant of theta is the reciprocal of the cosine of theta, and the reciprocal of 1 is 1 over 1, which is 1. The cotangent of theta is the ratio of x to y. So if we go to the x column, or the cosine of theta column, and divide that by 0, 1 divided by 0 is undefined. So the cotangent function is undefined at 0 degrees, and thus there's going to be a vertical asymptote where the cotangent function is undefined. We're going to get a VA, vertical asymptote, when you see the graph of the cotangent function. For 90 degrees, next row, which is pi over 2 radians, the y-coordinate, or the sine function value for 90 degrees, is 1. The cosine value for pi over 2 is 0. Tangent is y divided by x. So when you divide 1 by 0, that's undefined. So the tangent function is undefined at pi over 2, and thus there was going to be a vertical asymptote, or vertical boundary line, for its graph. The cosecant of theta is the reciprocal of y, or the reciprocal of the sine value. And since the sine value is 1, the reciprocal of 1 is 1, and thus that is the cosecant function value. The secant of theta is the reciprocal of x. X is the cosine of theta. Now, since the cosine value is 0, and again, 0 can be thought of as 0 divided by 1, the reciprocal is 1 divided by 0, which is undefined. 0 does not have a reciprocal. The secant has been discussed. Last column, cotangent. The cotangent of theta is x divided by y. So we'll go back to the x column and divide 0 by 1, which gives you 0. So that's going to be an horizontal intercept or x-intercept. Now the x-axis is going to be the angle theta. So instead of the x-axis, it's going to be the theta axis. The angle measure theta in radians. In the next row, 180 degrees, which is pi radians, the sine value, which is the y coordinate, is 0. The cosine value is the x coordinate is -1. The tangent is y divided by x, so you would divide 0 by -1, which equals 0. And since the tangent function value is 0 at 180 degrees or pi radians, the graph of the tangent function will intersect the horizontal axis. Usually we call it again the x-axis, but it's going to be the theta axis in radians. Next column, the cosecant of theta is the reciprocal of y, or the reciprocal of sine. And since the sine value is 0, and 0 does not have a reciprocal, the cosecant function is undefined at pi radians. The secant of theta is the reciprocal of x, which equals the cosine of theta. And the reciprocal of -1 is -1. Since -1 is divided by +1, the reciprocal is +1 divided by -1, which is -1. Lastly, the cotangent of theta is x divided by y, which is the cosine of theta divided by the sine of theta, which will be -1 divided by 0, which is undefined. -1 divided by 0. 270 degrees, which is 3 pi over 2 radians. The sine value is the y coordinate, which is -1. The cosine value is 0. The tangent is y divided by x, which is -1 divided by 0, which is undefined. The cosecant of theta is 1 divided by y, or 1 divided by the sine, which is -1. That therefore is -1. The secant of theta is 1 divided by x, or 1 divided by the cosine value, which is 0, and thus is undefined. The cotangent of theta at 3 pi over 2 is x divided by y, which is 0 divided by -1, which equals 0. And last row here, 360 degrees or 2 pi radians, the sine value is the y coordinate is 0. Cosine of 360 is 1. The tangent of theta is y divided by x, which is 0 divided by 1 equals 0. The cosecant of theta is 1 divided by y, or it's the reciprocal of the sine value, but 0 does not have a reciprocal, and thus is undefined. The secant of theta is the reciprocal of x, or the reciprocal of the cosine of theta, cosine of 2 pi, and thus the value is 1. Lastly, the cotangent is x divided by y, is the cosine of 2 pi divided by the sine of 2 pi is 1 divided by 0, which is undefined. Example 3, find the exact value of the following in part A. The sine of 5 pi. 5 pi radians starting from 0 radians would be 2 full revolutions around the unit circle, and thus that is 2 times 2 pi represents 2 full revolutions around the unit circle. But to make 5 pi, we have to go add 1 pi more, or travel a half a circle or a semicircle more. And when we terminate after an angle of 5 pi radians, we'll be on the x-axis, and the y-coordinate of the point that's determined, let's draw the picture here. So here would be the angle axis. And if we go around once, then twice, and then 1 pi more, pi radians more, then we'll be at this point P, where the sine value is 0. So the final answer is equal to 0. In part B, we have to watch for the argument negative 540 degrees is negative, and thus we have to think about an angle that's opening clockwise, CW. Now, if we subtract 360 from 540, we get 180, which is convenient, because 360 is 1 full revolution, plus 180 degrees is a semicircle, and we're going clockwise. So if we go clockwise, 1 full revolution, 360, then 180 more, will terminate on the x-axis at this point P. And the cosine value on the unit circle will be negative 1. Now, the following has been discussed in a prior class meeting: the construction of the special triangle, the 45, 45, 90 triangle. When you draw the altitude perpendicular from point P, you create an isosceles right triangle where these base angles are both 45 degrees. The two legs are equal or congruent. And by the Pythagorean theorem, we have x squared plus y squared equals hypotenuse squared. The hypotenuse is 1. And since it's an isosceles triangle, x and y are equal. So we have x squared plus substitution of x for y, we get another x squared equals 1. And therefore, we get 2x squared equals 1. So x squared equals 1/2. X squared has a coefficient of 1, so we can take the square root of both sides. Keep in mind that x is a length, so it has to be positive. So we won't get 2 solutions here. Technically, we do get 2 solutions plus or minus. We would get x is positive or negative, technically. Square root of 1 divided by the square root of 2. But since x is positive, we'll discard the negative solution, and x is 1 divided by the square root of 2. We then rationalize the denominator, multiplying by a form of 1, square root of 2 over square root of 2. And so x and y both are equal to the square root of 2 divided by 2 in a 45, 45, 90 triangle. So the cosine of 45 degrees is the cosine of pi over 4 radians is square root of 2 over 2, which is about 1.414 divided by 2, which is approximately 0.707. The sine of 45 degrees is the y length is square root of 2 over 2 as well, in this isosceles right triangle, and is about 0.707. Example 4, evaluate or find the exact value of the sine of pi over 4 times the cosine of pi, subtract the sine of 3 pi over 2. So you want to memorize certain facts like the sine of pi over 4 radians, or the sine of 45 degrees is square root of 2 over 2. The cosine of pi is the x-coordinate, which is -1, minus the sine of 3 pi over 2. 3 pi over 2 is 1.5 pi. So from 0, this would be 1 pi plus 1/2 pi more, or 1.5 pi. The sine function value is the y-coordinate is -1 on the unit circle. And the rest is arithmetic. So we have as an exact answer negative square root of 2 over 2 plus 1. And then you can get a common denominator of 2. And that could be written as negative square root of 2 plus 2, all divided by 2 as well, either way. In a prior class session, there was a discussion about the 30, 60, 90 special triangle. It begins with an equilateral triangle where all three sides are equal. Imagine that all three sides are 1. So we have this side is 1, bottom side, and this whole right side are all 1. So this is 1. When we draw the altitude that is perpendicular here, forming 90-degree angles, let's call this altitude segment AM. The angle that is 60 degrees is bisected. So it's cut in half into a 30-degree angle and a 30-degree angle. And so side BC, which has length of 1, is also bisected. So that means that y is going to equal 1/2. So from B to M, that distance or length is 1/2. And from M to C, that also is 1/2. And the 1/2 plus 1/2 totals 1. So since y equals 1/2, and you apply the Pythagorean equation, x squared, where x is the longer leg, which is across from the 60-degree angle. That is x. X squared plus y squared equals 1. So the longer leg, which is x, can be identified as LL for longer leg. LL squared plus y squared equals 1. Substitute 1/2 for y. here. Y is a half. And continue doing the algebra here. So we're going to have longer leg squared plus 1/2 squared is 1/4 equals 1. Subtract 1/4 from 1, so longer leg squared equals 3/4. Take the square root of both sides of the equation. And since the longer leg is a length, it's a positive quantity. So we'll take the positive solution. The square root of 3 divided by the square root of 4, which is 2. So the longer leg is square root of 3 over 2, which is across the 60-degree angle. The shorter leg is always across from the 30-degree angle and is the shortest side. The hypotenuse of one is always the longest side in a right triangle. So memorize that the cosine of 30 degrees is square root of 3 over 2. The sine of 30 degrees is 1/2. And also memorize that the square root of 3 is about 1.732. And when you divide it in half, you get approximately 0.8660. Now, the cosine of 60 degrees is going to be 1/2, and the sine of 60 degrees is square root of 3 over 2. If we draw a right triangle, let's draw it here on the unit circle. So here is an angle representing 60 degrees. And then we'll draw the altitude perpendicular. So that introduces the 90-degree angle. So we have 60 at the origin, 90, and then 30. The shorter leg is always across from the 30-degree angle, and it's always 1/2 the hypotenuse. And on the unit circle, the radius is 1. So here's the hypotenuse, length of 1. This point P is at 1, 0. And x, which is the cosine of 60 degrees, is going to equal 1/2. The sine of 60 degrees is going to be the length of the longer leg, which is across from the 60-degree angle. That's going to be y is square root of 3 over 2. So the point P above, x is the cosine value, is 1/2. But the cosine of 60 is 1/2, and the sine equals y equals square root of 3 over 2. Okay, let's evaluate example 5. Find the exact value of the tangent of pi over 4 times the sine of pi over 6 minus the sine of negative pi radians times the cosine of pi over 3. So let's start with the tangent of pi over 4. The tangent of an angle is the ratio of y to x, which also could be thought of as the ratio of the sine of the angle, which currently is pi over 4, divided by the cosine of the angle, which is cosine of pi over 4. For the angle pi over 4, x and y are equal. The cosine and the sine values are equal. They're both square root of 2 over 2. So the ratio is 1. So that's how we get 1 for this first factor here. The tangent of 45 degrees, or pi over 4, equals 1. Think of the isosceles right triangle where the two legs are equal. The sine of pi over 6, or the sine of 30 degrees, memorize that. It's 1/2. So you substitute that. Minus the sine of negative pi is an angle that's opening clockwise and terminates on the x-axis. And sine means y. So the y coordinate is 0. So the sine of negative pi is 0. And then the cosine of pi over 3 is the cosine of 60 degrees, which you memorize as 1/2. So you plug that in down there. And once you write out that expression, just follow the order of operations. So you get 1/2 subtract 0, which is 1/2. In a prior class meeting, there was discussion about how the 4 blue triangles are congruent, equal in shape, same size, same shapes, equal sizes. And so their corresponding lengths are congruent or equal. So once you memorize the cosine and sine of pi over 6, which is 30 degrees, that the cosine is square root of 3 over 2, comma, and the sine is 1/2, then 5 pi over 6, which is a multiple of pi over 6 here. If you follow this horizontal line and determine this point where the blue laser pointer is, it's going to have the same vertical distance y from the x-axis, have the same sine function value of 1/2. And it's positive because we're in quadrant 2, where x is negative and y is positive. Now the horizontal leg of the right triangle, down here at the bottom here, this horizontal, it's going to have the same length as the horizontal leg of the other triangle in quadrant 1. And therefore, the length is the same at square root of 3 over 2. But the point in quadrant 2 has a negative sign on the coordinate. So negative square root of 3 over 2. So basically, we're just going to need to copy the x and y coordinates from the point in quadrant 1, but adjust the SIGN, the sign on the x coordinate. And in quadrant 3, where the triangle is congruent, it's going to have the same length, but because the point is in quadrant 3, where x is negative and y is negative, both x and y are negative, The SIG and S, the signs, are both negative now. And lastly, in quadrant 4, both X and Y are positive, and therefore we'll just take the XY ordered pair, bring it down here to quadrant 4, and change the SIGN on Y, negative 1/2. So in terms of the multiples of pi over 6, we would have 1 pi over 6, 2 pi over 6 is pi over 3. Then we'd have 2/3, 2/6, then we have 3/6, which is 1/2. Then we're going to have 4/6, which is 2/3. Then 5/6 pi. Then 6/6, which is 1 pi. Then 7/6. Then 8/6, which is 4/3 or 1 1/3. Then 8/6. Then 9/6, and 9/6 is 3 over 2 or 1 1/2 pi. 9/6. Then we'll have 10/6, and 10/6 reduces to 5/3 pi. Then 11/6, and then finally 12/6, and 12/6 is 2 pi. Similar discussion for the 45, 45, 90 triangle. 45 degrees is pi over 4. And here again is this isosceles right triangle where x and y are equal. They're both square root of 2 over 2 in length. And the multiples of pi over 4 are going to be 2/4 pi, and 2/4 is 1/2. We could add that to this picture here, that 2/4 pi is the same as 1/2 pi, or pi over 2. So we have 2/4 pi. The next would be 3/4 pi, which is this angle that's terminated in quadrant 2 here. This is 3/4 pi. Here's the arrow indicating the angle that's terminating here, which determines the point from which we can draw this altitude, creating this congruent 45, 45, 90 triangle, and continue 5/4. 6/4 is 3/2 or 3 pi over 2. So this, on the negative y-axis, that's going to be 6/4 pi. 6/4 simplifies to 3/2 pi. So you have 6/4, then next will be 7/4. So that'll be the angle that terminates here in quadrant 4. And then 8/4, which is 2 pi. So these multiples of pi over 4 determine these 4 green triangles where the lengths x and y are equal in magnitude, equal in their absolute value, but you have to adjust the SIG and S, the signs on x and y, depending on which quadrant you're in. So let's pick one here for example. Let's talk about the cosine of 7 pi over 4. The cosine of 7 pi over 4 refers to this length x, which is positive, but the cosine of the angle in terms of this coordinates, x coordinate, is positive square root of 2 over 2. And the sine value for 7 pi over 4, the length of y is positive, but the y coordinate is negative. So we have to be careful when we say the sine of 7 pi over 4, are we referring to the length or the coordinate of a point determined by that angle 7 pi over 4? Lastly, with the orange triangles here, let's talk about the multiples of pi over 3, which is 60 degrees. The cosine is positive 1/2. The sine of pi over 3 is square root of 3 over 2. And when we generate the multiples of pi over 3, we have 2 pi over 3, 3 pi over 3, which is 1 pi, then 4/3 pi terminated in quadrant 3, 5/3 terminates in quadrant 4, and then 6/3 is on the x-axis and is 2 pi. So let's fill in. The cosine of 2 pi over 3 is going to be negative because we're in quadrant 2. It's going to be negative 1/2. The sine of 2 pi over 3 is square root of 3 over 2 positive. The cosine of 4 pi over 3 is negative 1/2. The sine of 4 pi over 3 is negative square root of 3 over 2. So be sure to adjust the SIGN, and I'll usually often spell it out to not confuse SIGN positive negative sign with SINE, the sine function. Lastly, the cosine of 5 pi over 3 is positive 1/2, comma, and the sine of 5 pi over 3 is negative square root of 3 over 2. Okay, as we've done in class, it is important to memorize and generate the cosine and sine values for these key angles and their multiples. The key angles are 30, 45 degrees, 60 degrees, 90 degrees, and their multiples. So let's fill this out here. 30 degrees, which is pi over 6. Remember, 30 times 6 is 180, is going to give cosine of 30 degrees is square root of 3 over 2. And the sine of pi over 6 is 1/2. 45 degrees is pi over 4. The cosine is square root of 2 over 2. And the sine value is the same. They're equal. Now for 60 degrees or pi over 3, all you need is to take this pair and transpose them. And we get the cosine of 60 degrees is 1/2, comma, and the sine of pi over 3 is square root of 3 over 2. Now there's a pattern here to help you memorize. If you look at the x coordinates and we go this direction counterclockwise, it goes square root of 3, then square root of 2, and 1 is the square root of 1. So you can think of it as square root of 3, square root of 2, square root of 1. And then when you look at the y coordinates clockwise, they go square root of 3, square root of 2, and 1 is the square root of 1. That's one way to memorize them. Okay, at pi over 2, which is 90 degrees, we have the cosine of pi over 2 is 0, and the sine of 90 degrees is 1. For 2/3 pi, which is a multiple of pi over 3, and notice that the difference when you subtract 90 minus 60 is 30. So if you add 30 to 90, you get 120. So we'll take this pair, 1/2 and square root of 3 over 2, but change the SIGN to negative for the x coordinates. So it's going to be negative 1/2 positive square root of 3 over 2. The next angle will be a multiple of pi over 4, right? We have pi over 4, then 2 pi over 4, then 3 pi over 4. And the coordinates will be negative, positive. So negative square root of 2 over 2, positive square root of 2 over 2. Now look at the pattern here. When you subtract 60 minus 45, you get 15, and 45 minus 30 is 15. So from 120, if you add 15, you get 135, and 135 plus 15 is 150. Also, from 0 to 30, you add 30, and from 150, you can add 30 to get 180, or from 180, subtract 30 to get 150. So on to the multiple of pi over 6. We have pi over 6, 2 pi over 6, which is 1/3, then 3/6, which is 1/2, then 4/6, which is 2/3, and then 5/6. And for 5/6, just read across here. So the cosine and sine are negative square root of 3 over 2 and positive 1/2. And then at pi radians or 180 degrees, x is -1 and y is 0. So the cosine of 180 degrees is -1, and the sine of pi radians is 0. For the next angle, 7 pi over 6, which is a multiple of pi over 6, the multiples of pi over 6 again are 2/6, which is 1/3, then 3/6, 4/6 is 2/3, 5/6, 6/6 is 1 pi, then 7/6. And for the coordinates, we can either just read straight up above and change the SIGN on y to -1/2. So we have negative square root of 3 over 2, comma, -1/2. 5 pi over 4 is going to be negative square root of 2 over 2, negative square root of 2 over 2. Thus, we would read, for example, the cosine of 225 is negative square root of 2 over 2, or the sine of 5 pi over 4 is negative square root of 2 over 2. Now for pi over 3, its multiples are 2/3, then 3/3, then 4/3, which you can follow back or trace back to 1/3. And the cosine of 4 pi over 3 is going to be -1/2. And the sine of 4 pi over 3 is negative square root of 3 over 2. Now here on the negative y-axis, that's going to be 270 degrees, or 1.5 pi, or 3 pi over 2. The cosine is x, which is 0. And the sine of 3 pi over 2 is the y-coordinate is -1. Now for the next angle here, to get 300, we can add 30. And 5 pi over 3 is a multiple of pi over 3. So you can think of it as the multiples of pi over 3 are 1/3, 2/3, 3/3, which is 1 pi, 4/3, 5/3, and then 6/3, which is 2 pi. So it's been on these coordinates. So we're going to have x and y both, sorry, x is positive, y is negative. So we're going to have positive 1/2, comma, negative square root of 3 over 2. From 300 degrees, you can add 15. And the next angle in terms of radians will be a multiple of pi over 4. Just follow that straight up. So it's going to be 1/4, 2/4, 3/4, then 4/4, 5/4, 6/4, 7/4. And like 1/4 pi, x and y are equal, both square root of 2/2 in magnitude, but y is negative. So square root of 2/2, negative square root of 2/2. Right? In quadrant 4, x is positive and y is negative. Lastly, 11 pi over 6. We can just follow that to pi over 6. 11 pi over 6 is a multiple of pi over 6. The multiples of pi over 6 are from 1/6, we have 2/6, 1/3. 3/6 is 1/2. 4/6 is 2/3. Then 5/6, then 6/6, 7/6, 8/6 is 4/3. 9/6 is 3/2. 10/6 is 5/3. Then 11/6. Then 12/6, which is 2 pi. And the cosine of 330 degrees is going to be positive square root of 3/2. And the sine of 11 pi over 6 is negative 1/2. When using your calculator, make sure it is in the appropriate mode. And for the cosine of 15 degrees to 2 decimal places, you would round that to the hundredths place at 0.97. In part B, the argument is pi over 12, and there's no degree symbol. So, and often when it involves pi, we often know that it's in radians. So your calculator needs to be in radians mode. You would evaluate the tangent of pi over 12 to 2 decimal places is approximately 0.27. Rounded to 0.27, 27 hundredths. Generally, for the secant function evaluation, there's not a secant button on a calculator, generally. So the secant of 10 radians is the reciprocal of the cosine of 10 radians. And with your calculator in radians mode, 1 divided by the cosine of 10 radians is approximately negative 1.19 to 2 places. Why did the value come out negative? Well, think about 1 radian is approximately 57 degrees. So let's sketch the scenario of an angle of 10 radians. About where would it terminate in what quadrant, which determines the SIGN of the cosine value. So pi radians, that's 3.14 approximately. 2 pi radians, well, 2 times pi is approximately 2 times 3.14, which is about 6.28, which is still under 10 radians. If we go a half of pi, pi over 2, so that would be 2.5 pi, or that would be 5/2 pi. Now pi is approximately 3, and 5 times 3 is 15, divided by 2 is about 7.5 radians. Now to get to 10 radians, we got to go a little further. So suppose we go 3 pi. Right, past 2.5. So at 3 pi radians, we terminate on the negative x-axis, and pi is approximately 3, so 3 times 3 is about 9. So we're almost there at 10, so it appears that 10 radians are going to terminate in quadrant 3, and so the cosine value is, in one sense, is the x-coordinate of this point P, which is negative. So that is an explanation for why the secant of 10 radians came out a negative value. So far, we've been referencing the unit circle. What if the radius is less than 1 or greater than 1, something other than 1, as you'll encounter in chemistry or astronomy? Although the sine and cosine functions are defined via the unit circle where the radius is 1, similar triangles can be used to show that the sine and cosine can be used on any circle with any radius. So let's look at this diagram here. Consider the circle where theta is defined in quadrant 2. Theta, you see here, terminating in quadrant 2, which determines point P star, which is here, and point P. Now notice there's a smaller right triangle formed here. We'll call it O, A star, P star, and it's drawn up here above, O, A star, P star. And that's on the unit circle where the radius is 1. The right triangle formed has legs X star and Y star. Now on this extended radius, we have point P drawing the altitude perpendicular, gives us point A, and then back to the origin. So that's triangle OPA, which is drawn over here. And the radius generally is R. The legs are X and Y. These two triangles are similar because of the two right angles being equal and because of this angle here. Let's mark it. And this angle here being the same measure, being congruent. So because triangle OA star P star and triangle OAP are similar triangles, that means the ratios of corresponding sides are equal. So that means we can write the following proportion. Y star is to the hypotenuse 1 as y is to hypotenuse of r. Also, we can write x star is to 1, the hypotenuse, as x is to r, the hypotenuse. And this third ratio, we can write the ratios forming the proportion y star is to x star as y is to x. Now, look at this ratio, y star to 1 on the unit circle. That is the definition of the sine of the angle. So this means that the sine of the angle theta which determines these y values, y lengths, they're equal. Those ratios are equal or constant. So although you can increase the radius from 1 to something greater, likewise you can decrease the radius and get smaller similar triangles. The ratios are constant regardless of the length of the radius. So the sine function value remains the same or constant for all similar triangles, smaller and larger. And the same with the cosine of theta. So for the unit circle triangle, or the larger triangle of radius r, the cosine value is constant. These ratios are equal and remain constant. And the same will be true for smaller or larger triangles. So when we use the sine and cosine functions, it doesn't matter how small or how large the triangles are relative to the unit circle right triangle. The trig function values are constant. They're going to be the same. The same for the tangent function. The tangent of an angle is the ratio of y to x on the bigger triangle. And proportionally, by similar triangles, it equals the ratio of y star to x star. So the tangent function value will be the same regardless of the size of the right triangle. Similarly, for the ratio of 1 to y star here, that is hypotenuse to the vertical leg, y star, as r is to y. Those ratios are equal, and the ratio values are constant, and 1 over y is the reciprocal of the sine function value, or is the cosecant function value, is constant regardless of the size of the triangle. The same is true for the secant function and the cotangent function. Their values are independent of the size of the right triangle. Notice that on the unit circle triangle, x squared plus y squared equals 1, right? The sum of the squares of the legs equals the hypotenuse squared. And on the general triangle, x squared plus y squared equals radius squared. So here are general definitions for sine, cosine, tangent, and their reciprocal values. So let theta be in standard position with the vertex at the origin of an xy coordinate system determining point P on the terminal side of theta. And by the Pythagorean equation, we have the sum of the squares of the legs equals the hypotenuse r squared. R is the radius of the circle. So generally, the sine of an angle is the ratio of y to r. And remember earlier, with respect to theta, y can be called the length of the side opposite. We're using the letter O for short for opposite. And r is the radius of the circle, which is the hypotenuse of a right triangle. And we have this mnemonic memory device. The sine of an angle is the ratio of the side opposite to the hypotenuse. The cosine of an angle is the ratio of x to r, and x is the length of the side adjacent, and we're using a capital A for adjacent, and r is the hypotenuse of the right triangle. So here's the mnemonic for cosine. The cosine of an angle is the ratio of length of the side adjacent to length of the hypotenuse. Ka. Tangent of an angle is the ratio of y to x. X cannot be 0. And tangent of an angle, theta, is the ratio of length of the side opposite, this is an O here, not a 0, to x is the side adjacent. So the mnemonic there is tangent of an angle T is the ratio length of the side opposite to length of the side adjacent. Cosecant of theta is the reciprocal of the sine of theta is going to be r divided by y. Secant of theta is the reciprocal value of the cosine of theta is going to be r divided by x. X cannot be 0. And the cotangent of theta is the reciprocal value of the tangent of theta is x divided by y. Y cannot be 0. In the last example, find the exact value of the 6 trig functions of an angle theta if 3, -4 are the x and y coordinates of a point determined by theta terminating in quadrant 4. So let's draw the terminating side of an angle. So here would be the angle theta, determining point P, where x is +3 and y, the coordinate, is negative. And keep in mind when we draw the altitude and draw what is called the reference right triangle, the length x is always positive and the length y is always positive. And the radius is the hypotenuse of a right triangle, and the hypotenuse is always across from the right angle. So this would be r, the radius. So the first step would be to find the radius from the Pythagorean equation. X squared plus y squared equals radius squared. X is 3. Y is squared here. So when you substitute for y, you can substitute +4 or -4. When you square it, it comes out +16 either way. And then 25 equals r squared. So on r squared, the coefficient is 1. So we could then take the square root of both sides. Technically, there's 2 solutions. R is positive or negative, but radius is a length or a distance, and therefore must be positive. So the radius is 5 units. So part 1, the cosine of theta is the ratio of x to r, is positive in quadrant 4. And thus we'll substitute for x, +3. The radius is always positive, so 3/5. The reciprocal value is the secant of theta. The secant of theta is the reciprocal value of the cosine of theta. So we just need to write the reciprocal of 3/5, which is 5/3. Part 3, the sine of theta is opposite over hypotenuse, or the ratio of y to r. Now y in this problem, on this diagram here, has a length that's positive, but in quadrant 4, the sine function value must be negative. And since radius is always positive, 5 in this case, the negative sign will go in the numerator. -4/5 is the value of the sine of theta. Part 4, the reciprocal value for the sine of theta is the cosecant of theta. The cosecant is abbreviated CSC. The cosecant of theta is the reciprocal value of the sine of theta. So we'll just form the reciprocal, and we can write the negative sign either in the denominator or on the side, either way. And part 5, the tangent of theta is the ratio of y to x. And because we're in quadrant 4, where x is positive, y is negative, the ratio is going to have to come out negative. Y is negative 4, and x is positive 3. Finally, part 6, the cotangent of theta is the reciprocal value of tangent of theta, or you can think of this as x divided by y. So the cotangent of theta is going to be the reciprocal of negative 4 divided by positive 3. You can write that as positive 3 divided by negative 4, or just have the negative sign on the side, either way.